Hi, this is Javier Encinas. In this video, I'm going to show you how easy it is to model and design a combined footing using ASDIP Foundation. To do that, I'm going to use one of the verification examples available in our website. This example has been taken from a very known, recognized textbook, Reinforced Concrete Mechanics and Design, 5th edition by Wright and McGregor. This is the example 15.4 in that book. This is what the example says. One column is 24 by 16. The load is 200 kips dead and 150 kips live. The other column is 24 inches square, 300 kips dead and 225 kips live. The distance between columns is 20 feet. Allowable soil pressure is 5,000. So basically, is this. That's what the example says. Two columns with these loads, 20 feet between them. The exterior columns is just at the property line, so the footing cannot extend beyond the column face. This is a limitation in the example that we need to take into account. The interior columns, yeah, no problem. We can extend the footing if necessary to do that. So this is what the example says. Okay, let's open ASDIP Foundation. This is basically, I'm going to show you the numbers again as a reference. Well, let's see how simple it is to model this combined footing. The software is designed in such a way that these tab pages let you define the input data very easily, very straightforward. For example, in geometry, you can put here in the footing tab distance between columns. We know that is 20 feet, and this is the dimensions of the columns. We're going to propose some thickness of the footing. It's not given in the example, of course, it's part of the design. So we're going to use 40 inches, and we can change it later if necessary. Columns, this is the column sizes given by the problem. 16 by 24 is the exterior, 24 by 24 is the interior, 24 by 24. So this is given by the example. In the loads tab, well, we can input. The program allows you to either use a pre-combined loads if you have already the reactions given by analysis program and you just need to input those loads here. You use this option. Just either service and factor loads given by the analysis program. If they are not combined and you need to combine it in ASDIP, well, then you select this option and you're given these alternatives here: dead, live, roof, live, snow, wind, and seismic. In the example, we're going to use this option, of course, because we need to combine the loads internally. It's given by the example that the dead load is 200 in the exterior and 300 in the interior. Live is 150 exterior and 225 the interior. So this is given, very simple to input. Materials is also given by the example. So concrete and steel capacities. Soil bearing pressure is also given, 5,000, 5 KSF, and the columns also, F prime C, Fy, and for the concrete and the rebars. And finally, the reinforcement tab. Here you can input all the rebars for the footing and the rebars for the column. This is part of the design as well. So you can change everything you need or necessary to make your example pass all the checks. In the output side of the program, you can check here just at a glance what went wrong or if everything passes. In this case, for example, this one-way shear in the interior column is failing just by 9%. So we need to address this issue during the design to make it pass. In the Contents tab, all these numbers are shown, but in more detail. The overturning calculations and all, the two footings at the exterior column and in the interior column, all the details are here. The sliding and the longitudinal reinforcement, materials, and uplift calculations if necessary. In the Detail tab, all the calculations are shown here, but step by step and with the exposed formulas. Everything is exposed, so nothing is hidden, and code references also for easier reading and easier following of the calculations. So very nice, very simple. Okay, so basically this is the example that we are designing right now. This footing, well, for example, we're going to use a footing that is 8 feet wide. We can see it graphically here. It's 8 feet wide, 20 feet between columns, and we are extending in the interior footing 466 feet. All these dimensions can be changed. Of course, I know that these are the numbers that are given in the example, or where the example is solved in the textbook, but I can optimize all these and I can check it. For example, the bearing pressure here is 5, the allowable bearing pressure, and the maximum bearing pressure in the columns, under the columns in the footings, is 4.9. It's very close, so it's almost there. It's almost there. So if we change, for example, here, instead of 466, we put 5 feet. Of course, this affects the numbers, affects the exterior, and so on. So the idea is to modify the numbers here and play with the numbers and see the effect on the right side and optimize your design. Obviously, in the example in the textbook, the authors already took care of all this, and the example is optimized. So they know that the bearing is going to be very close to the allowable pressure. But in ASDIP, in the example, you can change any dimension, any parameter, and see the effect here. Particularly with the rebars. These are the rebars using the example, but you can change any dimension, any rebar if you want, sizes or number of rebars, and see the effect. So the idea behind the philosophy of ASDIP is to provide a tool that you can use to be in control of your design and change whatever you want in order to optimize your design. The program is completely updated with the latest codes, ACI 14, so it's very reliable, and the most important is that it's user-friendly. You can input the information as you just saw here. It's very, very simple and very straightforward. Okay, thank you for your attention. I'll see you in the next video.